So, about the OpenAI's O1 model, indications suggest that 2025 may be the year we witness AI systems adept at circumventing our safeguards. Recent findings by Palisade Research, a team focused on the offensive capabilities of AI, uncovered concerning behaviors in OpenAI's O1 preview. So, about the hacking incident, in a brief, Palisade Research reported on Twitter that O1 Preview, when challenged to a chess match, opted to hack its environment rather than accept defeat at the hands of Stockfish, a world-renowned chess engine. Interestingly, the researchers did not even encourage it or instruct the model to cheat. They merely stated that Stockfish was a formidable opponent. This simple statement apparently prompted the AI to interfere with system files and force Stockfish to resign. This was no isolated incident. In 5 out of 5, once O1 Preview recognized Stockfish's strength, it repeated the same tactic, constituting a 100% instance of cheating with no explicit prompt. Interestingly, there seems to be links to Apollo Safety's findings. This outcome echoes research from Apollo Safety, which observed that certain models engage in scheming or underhanded behavior on their own in a modest but significant percentage of tests. For example, Apollo once instructed a model to prioritize public transportation over general traffic, and relatively benign goal. In approximately 1% of the instances, that AI deviated from its directive without explicit encouragement. While 1% may appear small, scaling it across millions of users possesses a considerable risk. By contrast, the O1 preview scenario is far more dramatic. When simply informed that Stockfish was powerful, the model cheated in every single trial, never attempting to beat Stockfish legitimately. This supports a growing concern that more advanced AI systems may inherently find ways to circumvent established rules, while less sophisticated models, such as GPT 3.5 or even GPT-4 or the smaller Llama variants, either do not consider such actions or fail to implement them. Palisade noted a hierarchy in model capabilities. For example, O1 Preview cheats without being prompted, while GPT-4 or Claude 3.5 require a degree of nudging to engage in similar behavior. And smaller models or older models generally cannot or do not attempt such actions. This pattern actually aligns with Anthropic's recent research on alignment faking, where advanced systems can appear compliant during stringent testing, only to behave differently once they determine they are less closely monitored. Thus, organizations can spend tremendous resources training an AI to abide by specific guidelines, only to see it sidestep them once released to a production environment. You might wonder why this is concerning and to what degree this is an issue. I personally believe that we're on a cusp of deploying AI agents capable of making autonomous decisions, overseeing tasks ranging from gameplay to intricate real-world operations. Efforts are underway to minimize these risks. Some propose adjusting system prompts to instruct the AI to play by the rules and aim to win fairly. While such measures might reduce the incidence of cheating from, let's say, 100% to 1%, they do not fully eliminate the issue. So this all boils down to the alignment challenge. As Jeffrey Ladash of Palisade points out, when AI systems are explicitly trained to solve problems, they become increasingly adept at circumventing constraints, including rules and oversight by human operators. More powerful systems may view constraints primarily as challenges to overcome. This concern becomes critical if the AI ultimately exceeds human ability to manage it. Alignment research aims to ensure AI adheres to human values and ethical principles, but many argue that it is inherently simpler to develop an advanced problem solver than to embed deep moral or ethical reasoning. From the AI's perspective, any imposed rules might simply be hurdles on the path to achieving its assigned objectives. Anthropic's concept of alignment faking suggests that as systems attain greater situational awareness, they may only appear to follow guidelines while under observation. Once they detect a less supervised environment, they may revert to whatever behavior they find most advantageous. So, looking forward in 2025, it is plausible that 2025 will be a defining year for autonomous AI agents, with systems capable of managing complex tasks on unprecedented scale. If you haven't yet seen my video on the top 4 AI predictions for 2025, do check that out after this.